Hello and welcome to PA Academy. So this is the example 2 under combination with condition. So if you just come across this video and you missed the part 1 or the previous part of this video where we looked at combination without condition and we've looked at permutation, kindly check the description of this video. You'll find a link to those videos. So for this example 2, it says, in a class containing 18 boys and 12 girls, a committee consisting of 5 boys and 4 girls is to be formed. How many ways can this be done if, now these are the conditions. Don't forget we are looking at combination with condition. We are looking with condition now. So these are the conditions. If there is no restriction, and so if a particular boy and girl must be included. So these are the two conditions. So let's start with the first part of this question, which is the first condition. It says that what if there is no restriction. But before we do that, let's bring out some of the necessary details or parameters from the question. It said in a class consisting of 8 boys. So that means the total boys is 18 and 12 girls. So total girls is 12. It's 12. So a committee consisting of 5 boys. So our committee so the committee for boys So committee for boys is 5, and then 4 girls. For the girls is is 4. So with all these stories, this is just what they are trying to say. So don't let when you see a question like this that it looks very long, with too much text, don't let it to scare you that it's very difficult. So we've been able to bring out the necessary details that the total number of boys is 18 and total number of girls is 12. Now they want to form a committee, and that committee must comprise of 5 boys and 4 girls. Now the first condition says that if there is no restriction. So if there is no restriction, how can they form a committee whereby they will from a total of 18 boys, they are going to have 5 boys. From a total of 12 girls, they are going to have 4 boys to form a committee. That means total number of committee will be 9. So out of that 9, there will be 5 boys and there will be 4 girls. How can they do it if there is no restriction? It's just like saying that without condition. So that's what this question says, that if there is no restriction, that means if there is no condition, how can they do it? Now, so for this, don't forget the formula when we are dealing with combination. That is n. So n, which is a superscript, combination r, is equals to n factorial over n minus r factorial times r factorial, whereby this n represents the total number of objects or elements to be chosen. Total number of objects or elements in the set. Why this one is total number of elements to be chosen. I've talked about this in the previous part, but let me just write it here. N is total number of objects in the set. Why R is total number of objects to be chosen. So either to be chosen or to be selected. You are still saying the same thing as long as combination is concerned. So back to the first question, which is, so you can write this down so that because I'll be rubbing it off because of space. So the question says that if there is no restriction, how can we pick 5 boys from 18 girls? 5 boys from 18 boys and then 4 girls from a total of 12 girls. So let's do that. So if there is no restriction and we want to pick 5 boys from a total of 18 boys, look at this. So like I said, our n represents the total number of objects in the set and r represents the total number of objects to be chosen. So the total number for the boys now, so the total number of boys is 18. So that will be 18 combination, and then and then the r, which is total number of objects to be chosen. That means total number of boys to be chosen represents 5. So that is this side for the boys, then times. Now let's look at the girls. Our n for the girls is what? Which is the total number of objects in the set, that is the total number of girls, is n, that is 12. So that will be 12 combination. Then our R, which is the total number of girls to be chosen or selected. Look at it, computing for girls, that is 4. 4. So now, by the time we simplify 18 combination 5, so in simplifying 18 combination 5, that will be 18 factorial over, I'm applying this formula, over 18 minus 5 factorial times 5 factorial. So this is it. Then multiply by, for this, that will be 12 factorial over 12 minus 4 factorial times 4 factorial. So now we can, I want to rub up this question since we're bringing out the parameters. So by the time you evaluate this 18 factorial over 18 minus 5 factorial times 5 factorial, I won't be going beyond these points because I believe by now, if you have been following this video from the beginning, you know how to simplify this. So if you simplify 18 factorial over okay, let me just go one step further. So that will be 18 factorial over 18 minus 5, that's 13 factorial times 5 factorial, then times 12 factorial over, so 12 minus 4 over 8 factorial times 4 factorial. So if you do this, you are going to get 8,000. So 8,568 times, so 12 factorial divided by 8 factorial times 4 factorial. So that will give us 495. 495. So by the time you multiply 8,568 multiplied by 495, so that will give us, okay, that will give us 4,241,160 ways, and that is the answer with when there is no restriction. So if there is no restriction and we are asked to pick a committee of 5 boys and 4 girls from a total of 18 boys and 12 girls, we can do that in 4,241,160 ways. So this is the solution to the first part where there is no restriction. So now let's look at the other part which says that what a particular boy and girl must be there.